This is a tech diary for analysis of this project, a third-person camera project on GitHub that's based on this article, the 6 ingredients for a dynamic third-person camera. And on this article, the last link there is the source code that comes to this project. So in particular, I wanted to document the part about the camera modifiers and how it calls the process view rotation function that's on a lot of the camera modifiers, and in particular with the spring arm and how that comes into play. What's the role of the spring arm in terms of the camera modifiers, in particular to this project? Because there are a lot of different ways to use it, but how this project sets it up and uses it in general. So the player controller um, is kind of where it starts. But let me show how it works first. We're going to be looking at one of the camera modifiers is this this pitch control. So you see this pitch control where it moves up and down, and that's the pitch. It moves according to a curve. You can see when it gets out to a maximum on the curve, this is the max, and it goes in slowly, and it flattens out at a particular point. This is where the curve starts, see, and where the curve ends. Okay, so this curve here marks out that motion path for the camera. And this one, this curve is being used in the camera modifier called BP camera modifier apply pitch curves. Here, you can see where this is where the curve is located as the asset. Okay, so going back to the code, we have the third person character, and the way they've set it up, the camera is basically right up on the character there. It's right next to him. So there is a camera boom, but it's basically there's no length. There's no, so you can see here, target arm length is 0. And it's off-centered by the socket offset. So 40, 40 on a Y and a Z. So it's 40, 40 up. And the important part will be that the follow camera component is a child of the boom camera. Oh, sorry, the camera boom. It's a child of the camera boom component. Okay, so this is going to be very important as I go through the code. And that's what I'm going to do right now. So the player controller, this is the base class, the actual engine code for the player controller. So it goes to the player camera manager and calls process view rotation. So in the camera's function for process view rotation, then it goes through each of the modifiers and it calls the process view rotation for each of the modifiers. And this is where we come to our function for the process view rotation. So for example, this is the pitch curve. This one only has a modified camera, but if you look at another example, say this one, it overrides process view rotation. It gets out view rotation and out delta rotation as an in and out parameter. So these are both in and they are both out, and it accumulates and it's called from the player controller. The accumulation starts from the player controller. So you can see this. This is the main guy, view rotation. It gets the control rotation. If you go in there, it just returns the control rotation as the variable, and it puts it into this process view rotation, and then it accumulates over each one of the modifiers on the player camera manager. And it gets accumulated, and then each call to process view rotation for each of the modifiers accumulates this out view rotation and then the out data rotation. And at the end, uh, it adds the last out delta rotation to the out view rotation and zeroes out delta rotation. Okay, so that's one thing. The other thing is the spring arm and how that works. And the spring arm will be in the spring arm rotation, or in the spring arm component here in this function. Update desired arm location. So what's the relationship between spring on the camera? It seems, because the question is, it seems that the camera modifiers are modifying the rotation of the camera directly. So what's the role of the spring arm in all of this for each of the camera modifiers? And through looking at this code, the gist is that the spring arm basically at every moment of the tick is doing this update desired arm location. And all it does is it takes the view target, which is the player character that you're controlling as the player, takes that location and backs up the camera using the length, this length of the arm length, and it just subtracts that length times the view, the forward vector of wherever the rotation of the forward vector of the character is. So it just backs it up at every tick. So basically, it's the center fulcrum is the player, it's the view target. So if you look at this, this is the desired variable, get target location, and just gets the target location, desired location, get component rotation. Let's see. Get target rotation. It just gets the target rotation from the world space. Get the desired rotation from the world space, component rotation. So basically, this is where the component is in the world, which is on the actor, on the player. And then we can skip this part because, assuming we want the simplest version, we don't care about rotation lag, and it just sets the previous rotation to what we want. And also, we need to not care about this location lag as well. And it just says the arm origin is where basically our character is, and it just adds the target offset to it. And the arm origin. Now, if you go down, you ignore this part. This is where the magic happens. So it just subtracts from this rotation vector the target arm length times. So whatever this length is, I assume this is like a normal vector. So the desired location just backs up from the player location times the arm length at every moment of the tick. And then it also adds the socket offset as well as a finer detail refinement. And then we can forget about the dew trace. But if we do want to know about the dew trace, it's got the sweep in there in case you swing the camera into the ground or into a ball or something like that. If you turn this on, then it won't do that. It'll just give you back the position where the last hit was. Okay, and then down here, it sets these transformations and sets these variables to the location, the rotation, and it does update child transforms. And here is where the magic happens. It gets a list of all the children and updates their transforms according to this parent that we just did. And this is where this comes in. The camera boom, its children is the camera. One of its child, or its only child, is the follow camera. So this is the step that updates the camera's location along with the boom, the camera boom logic, the update logic. So, and then we'll backtrack and see that. See, backtrack a little more. No, this is too far. I think here. No, back. Here, this update arm desired location. Okay, we got there. And you got here, update desired arm location is where it's being called as well on every tick. So every tick, basically, it's doing, looking at the view target, which is the player location, and backing up the camera based on the boom stand's length. Back, back, back. And so in this case, the boom stand length is 0. So how come we get this nice, seems to be something like a boom stand? Is this because of one of the camera modifiers, that which is the pitch modifier, apply pitch curves, this guy, where the curve comes in. So if you look at the code there, this pitch curve, pitch curve, apply pitch curve on its modified camera call, it is, so this location is constantly being modified. The desired location is the camera location minus the rotating vector times pitch to distance. And then pitch to distance is the value it gets out from the curve asset. And the curve asset, it goes from, the pitch goes from around -90 to +90, about there. So only in the very middle you get this curve, but most of the way you get a flat curve. And you can see that here when you find pitch. Yeah, there, pitch min is about -90. Pitch max is also about -90. So that means you can go about there, about 90 and negative 90. So those are the max. And from the curve, those are the values that it gives you. About 200 up to 300 back to 200. So the boom length is it's always between 200 and 300. So you can see this is the furthest, this is 300. As you go up, it gets closer. So that's flat, that's flat 200. And you go down, it backs up to 300. The curve comes back down to 200 and it remains flat at 200. So this is what causes the illusion of a boom, camera boom. It's that camera modifier, this apply pitch curve modifier that's constantly doing the camera boom's job. And more to be discovered about the other call that's common on camera modified, this modified camera, to track how it comes through and how it gets called in the infrastructure of the player controller and the player camera manager. And maybe the spring arm will be involved, but probably not. But that's all I have for today. It's kind of a long video. So there you have it, is a tech diary. Thanks for watching, if you did, for sticking to it this far. And talk to you guys later.